in this combination of circuits question number 3. So again, I will draw out this question. So I've got a 20 ohm resistor in parallel with a resistor of value R, so that's these two in here. And then they're in series with a piece of apparatus A, and the whole circuit is connected to 100 volt supply. So we've got to find the value of R, so that apparatus A shall dissipate 600 watts with 10 amps passing through it. So the solution to this problem is I know that this, or the way through it is, I know that this is 10 amps flowing through apparatus A, and I know I want it to dissipate 600 watts. So I can use the formula for power to find out what the voltage must be across apparatus A so that it dissipates 600 watts of power. That will allow me to calculate what voltage remains across this parallel combination here. And then once I work out what that is, I can work out what total resistance that needs to be to allow for that voltage 10 amps to flow altogether, because it must be 10 amps here. And then once I've got that total resistance, I can find the value R must have to give me that total resistance. So that's the way through the problem. So the solution will appear below. Let's see if you can work it through yourself. Okay, so to start off with then, the voltage across my apparatus A, must equal the power that I want to dissipate, which is 600 watts divided by the current through that apparatus A, which is 10 amps. So that gives me 60 volts. So what voltage must be remain across the parallel combination? It must be the total voltage, which is 100, take away that 60. So I've got 40 volts across here. I've got 40 volts across there. So now, if I know the current, as I've said, flowing through this little combination, I can work out what the total resistance needs to be, and then go and see if I can use that to find the missing resistance. So there's a bit of algebra involved with it, and that was similar to the one question we did earlier. See if you can go ahead and finish this off and how to find the value of R, which should be 5 ohms. So we have that. The resistor in parallel combination must give us a total resistance of 4 ohms. The voltage of 40 volts divided by the current of 10 amps gives us 4 ohms. So RT is 4. Using this formula, RT is R1, R2 over R1 plus R2, product over sum. We have that the total resistance 4 ohms must equal 20 times the unknown resistor divided by 20 plus the unknown resistor. So now algebra rears its ugly head, and we've got to rearrange this to find R. I would suggest the first thing you do is multiply both sides by this expression underneath, then expand, collect together like terms, and find R. So see if you can finish it from here. I actually saw a shorter way as I was doing this. So first of all, multiply both sides by that expression underneath. I get this. I could expand it out at this point. 4 times 20 is 80 plus 4R. That's perfectly okay. But actually, I could divide both sides by 4. So if I divide this side by 4, I'm left with 20 plus R. Divide this side by 4, I'm left with 5R. So I get to here, and it just makes it a little bit more straightforward. Now subtract R from both sides. I get 20 equals 4R and R equals 5 ohms. Either way, you should get the same answer. So there's a solution to that particular question.